arrested on suspicion of committing a felony in Brooklyn, New York City had a 20% chance of ultimately serving time in jail. Of 4 arrests in a Brooklyn precinct, what is the probability that at least one will serve a jail sentence? So this is what's considered a binomial distribution problem. And what you're looking for is a probability. This is called a P. N is the like sample, we'll say. And then there's usually a phrase like at least one, or less than one, or greater than two, or less than two, or exactly 0, or something like that. And that's the third piece. All right. Now, are you allowed to use a calculator, Excel? What are you allowed to do?
Actually, I don't know if we're allowed to use a calculator. I know we're allowed to use Excel.
All right, so let me pull up Excel and I'll show you how you would do a problem like this one in Excel. And then I'll send this to you at the end so you've got it.
Okay. And so for the N you said that's sample, right?
Yes.
Okay, I put that in parentheses next to it, so just making sure.
Yes. Okay, so let me new share this other screen. All right, and we'll call this one binomial, so you can use it for all your binomials.
Okay.
So the we'll P, let's leave it as P, but this means success. All right, Q is well, they rarely give you Q, so let's not do that. Let's do size, sample size, N, which is your size. Okay, and then this is your X, which is the what's the right word for that? But it's the at least one, the less than one. This is like your comparison.
Okay.
So let me put your numbers in here. So 0.2, 4, and then 1. And so the problem is there's actually all these different possibilities. There's less, let me try this, equals X. Let me do it this way, equals X. There is, so let's just do that one. So if I type in binom distribution, binom.dist, it asks for a bunch of different arguments. And this is where most students struggle because they don't know what to put here. So the first one is your X. The second one is the number of trials. And then the third one is your probability of success. And then we want false on this. I'll explain that in a moment. So this is the probability of exactly one arrest in your problem here.
The 0.40.
96, yeah. So if I change this to 0, why didn't that update? That's odd. Okay, that's because they're the same. All right, so if you change this, you can see that it 3 arrests, 4 arrests, and so on. So there's some symmetry in it. So then, but what you want in this problem, it says at least one, and I guess I need to go back to the other screen for a moment here. So let me go back to that. So what this problem wants, it's the probability that X is greater than or equal to 1, which means the probability that X equals 1 plus the probability that X equals 2 plus the probability that X equals 3 plus the probability that X equals 4. And you can see the problem with this is that it's a lot of things that you would have to count or add up at the end. Mm-hmm. So if we were to just make a list of all the possible outcomes, it's either 0, 1, 2, 3, or 4. Do you agree with that? Either 0 people. All right. So greater than or equal to 1 is this grouping. So what you really want, since you want all of those, but they all add up to 1, they all sum to 1. What you can do is you can use this 1 minus rule. So you can do this 1 minus the probability that X equals 0. Because once you get that value, 1 minus it is these other 4, or you can get all 4 of those values and add them up. But you'll soon see especially if this size 4 gets larger. Okay, like you don't want to be adding up much. Like let's say it was 40, you wouldn't want to add up 1 to 40. That would take too long.
Yeah.
So that's why they ask this question. They say at least 1 because they want to know, will you calculate the probability that it's 0 and subtract it from 1? Okay, so in terms of like what you want, let me go back to this calculator here, because this will save us some time here. So sometimes you want exactly equal to X, but what a lot of times you want less than or equal to X.
Okay.
Okay, and so it's very similar. I'm going to do the formula again here. It's 1 because that's our X value. The number of trials is 4. The probability of success is 0.2. This time it's what's called a cumulative because it's adding them up, and we do that. Okay, but sometimes you want just less than X, and what that means is you don't include the X value. You actually want this one minus 1. So, and this is the power of Excel here. I mean, I don't recall how much you've used it, but you can change, once we have all these formulas in, you just change the first 3 cells up here, and you'll be able to get the answer to any problem you want here. So it's a lot of work, but then everything goes faster. So this time, the number of sample or the number you care about is not 1, it's 1 minus 1, because you want less than X, so you exclude that value. And
Okay.
then 4 trials, this, and then you want true again here. So then you can go the other way. Well, what if you want what if you wanted greater than X, or greater than or equal to X? Let's do that one first. So greater than or equal to X is actually 1 minus less than X. So you don't have to recalculate it each time. And then greater than X is 1 minus less than X. I'm sorry, less than or equal to X. And so these are the only possibilities. Like you have to look at cell 4 and be like, it's probably that X equals 1. 5 is less than or equal to 1, and so on.
Okay.
So in terms of like this problem, you want at least 1. So you want this value right here, greater than or equal to 1. So this is your answer, because it wants at least 1. At least 1 means greater than or equal to 1. Now, just to confirm that you believe me here, or just to show you this. So if I do the binomial distribution for each of these values, so there's this number, it's 4 trials, it's 0.2, it's false. Okay.
Mhm.
All right. So if I were to sum up, if I were to add up 1, 2, 3, and 4, you see that that's the same value as greater than or equal to 1. And we'll probably get to do this in a few more problems. So we'll get to reuse this this sheet here. But let me jump back to it, to the problem here. So the answer is 0.5904. And what we did on the Excel is we made this template that we can reuse in other problems. So like just doing one question we can do, it takes a long time, but now you're going to see the power of this. So let's look at question number 2. That's why I asked whether you can use Excel or not, or your calculator, because there's different ways to do it. Well, of course, this is not a binomial distribution problem. Oh boy, maybe you're not up to there yet. I may have just wasted a little bit of time. Yeah, I did. I apologize. Okay.
It's okay.
You will see that again, but not today. Okay.
Okay.
It is found that 25% of the families interviewed by Newsweek and 40% by People, if the events are statistically independent, what is the probability that a family will buy neither magazine? So usually they ask like, what's the probability that they'll buy both? But of course your instructor's this weird obscure one that asks like the odd question. But but this is another Venn diagram problem. In some ways. So but you do need the probability of both or the probability of and. And in this case is when you just multiply the numbers together, 0.25, 0.4, and that's because they're independent. So when they're independent, you'll see this probability of A and B equals probability of A times the probability of B. Great. So 0.25 times 0.4 is 0.1. 0.1 is what goes in the middle. Okay, and let's just say this is Newsweek. And this is people. If this whole circle is 25%, that means this one on the left is 0.15. And if this whole circle is 0.4, that means this is 0.3. The neithers are out here. These are the neithers, or the neithers. So we got to add up these three numbers, 0.4, 0.55. That means it's 0.45 buys neither. And that's it.
And so that's the answer.
That's the answer. Now there's the more sort of like, there's the probability of A or B, which is the probability of A plus the probability of B minus the probability of A and B. Okay. And that's essentially what we use to find this, which is not the answer because that's that number there. What you want is 1 minus the probability of A or B, because 1 minus means everything except what's in the circles.
Okay. Can you re-explain the thing underneath it, like with the written part, the P, like A or B?
This is just a formula. It's and I don't think it's very helpful because I think the picture is easier. But it's exactly what we did. You add
So
up
that is exactly the same as the picture above.
Yeah, because we did 0.25 plus 0.4 minus 0.25 times 0.4. And you get that got us the 0.55. A or B means so when your Venn diagram, your A or B is all of this stuff inside the circles. That's your A or B. So neither means outside of that.
Okay. Oh, I see what you, because exactly it adds up to the the A and B. I see now.
Yeah.
You took the middle one.
Yeah, I mean, you and I don't buy magazines. I don't know anybody who buys magazines very often.
Yeah, I don't.
That's a weird question, but neither means you literally don't want either option. You don't want one or the other or both. You don't want any of them. So,
what would be the answer if it was the way they would usually ask it? How would you do it?
Like
if you'd buy both.
That's yeah. You just multiply the two numbers.
And it'd be 1.
0.1.
Okay. Oh boy, 0.1. So I was like 1 would be 100%. Okay.
So this is a good time for me to remind you that probabilities are always between 0 and 1. They're never greater than 1.
So that's when I was like, I took like, I don't know why I didn't see the dot for a second, like the 0.1. So I was like, 1 would be everybody buying.
Yes.
So, that's why I was confused for a second.
And we already know that's not true.
Yeah. That's why I was like, yeah, so that makes more sense. Perfect.
All right, so this is another kind of I think we did one like this before, maybe with something else, socks or something, but two balls are to be drawn without replacement. So that's key, without replacement. That means you're not putting them back in. You might think, oh, well, that's obvious, but some problems do say that you put the ball back in after each time. The urn contains 2 white, 3 black, and 4 green balls. It's good to get a total. You always want a total, so that's 9. What is the probability that both balls will be the same color? So it's a both again, but it's slightly different than the previous problem because you can actually sort of visualize what's happening here. You've got 2 white, 3 black, and 4 green. And what we first want, the situation is the probability that you get, either, well, so, okay, let's see, just going here. So we need to actually write out all the possible things that could happen to get the same color. So you could go white, white, black, black, green, green. And we actually, so like normally the first question they ask you is what is the probability that both balls will be white is the first, like, that's sort of the starter question for this.
Okay.
But what we're doing here is it's now an or. It's white and white, or black and black, or green and green. Any of those are good. Now, when you have an or, you add them up. So the probability of white, white, plus the probability of black, black, plus the probability of green, green, we're adding those because they're an or. But individually, white and then white is an and. So this is probability of white on the first ball times probability of white on the second ball. And because you can just, it's the language. It's like white and white, but or the other possibility of getting the same color. That's why it's added, but this is multiplied. And it comes from that word, or generally implies add, and generally implies multiply. Is that okay?
Yeah, that makes sense, I think.
All right. So in terms of getting a white on the first ball, there's 2 white out of 9. But we assume that we have pulled a white out. So how many are left over? 1 white. And how many total balls are left over? 8. Okay. Now, when we go to black, black, you're restarting it. It's like going down the cases of like, well, what if I start out now actually getting a white ball? I'm sorry, black ball, and then another black one, or marble, or whatever these are. But you restart your thinking. Like you don't say, oh, there's 3 black and there's 8 left over. No. It's that there's 3 black out of 9 because you're starting this simulation over again.
Okay.
But then you do assume, hey, I grabbed one, so there's 2 left out of 8. Okay, and then same thing with the green, green, you restart everything. You say, okay, I'm going back to the original. There's 4 green out of 9 total. I assume that I grab a green, and then there's 8 left over. All right, so the way to answer this, 2 times 1 is 2, 3 times 2 is 6, 4 times 3 is 12. That's 20 over 72, which reduces to 10 over 36, 5 over 18. Any
Okay.
questions? Any questions on that?
No, that makes sense.
All right.
Yeah, it clicked. Once you started doing like the fractions below it, it started to click.
Okay, let's go to 5. We'll come back to 4 because it's another one of these marble things. Okay, suppose we have a box with 13 red, 12 blue, and 5 whites. So that's 25 total. Or I'm sorry, 30 total. We select 3 balls from the box one at a time. Once a ball is drawn, it is not returned to the box. There's no replacement. That's what that means. No replacement. Find the probability that the first ball drawn is white, the second ball drawn is blue, and the third ball drawn is white. All right, so it's the probability that the white is the first ball, probability that the second ball is blue, and the probability that the third ball is white. So this is a sequence, and like it has to be in this sequence. So it's I mean, in the way you want to like sort of process is like think about something else in your life where you do in order, and to me it's an and I'm just going to say that, not try to ask you. Like it's like thing 1 and thing 2 and thing 3, these all have to happen. You know, if you turn on your TV, you got to grab the remote, hit the button, you know, something like that. Like there's certain sequence that has to happen here. So that's a multiplication because it's an and. So these are like when you see sequences, that the order matters, which is what's going on here, because it says first ball must be white.
Mhm.
Okay, so we know there are 30 total balls, and like we assume good, like we assume we actually are getting a grab of a white ball. Okay, so we add, there's 5 that we can grab. We assume we grab one of them out of 30. Now the blue, how many blues are there? There's 12, but since there's no replacement, there's 29 left over. And white for the third ball, well, there's 4 now because we assume we grabbed one there, and then out of 28.
Okay, that makes sense.
All right, so let's go back to 4. Suppose that in a given large population, there are equal number of males and females. In this population, 5% of the men and 0.25% of the women are colorblind. A colorblind person is chosen at random. What is the probability that the person is male? This is one of those tree problems where you really should go down and get the branches. It may not be apparent because they don't give you the probability of male and female. They just say they're equal. So that's 0.5 and 0.5. So now this is where we actually care. Okay, it says in this population, 5% of men and 0.25% of the women are colorblind. So what we care about is colorblind, and then not. Color blind, and then not. So male is 0.05, and then female is 0.0025. And since there's only 2 outcomes, we assign the 1 minus to the other side. Do you remember us doing this last time we made a tree for at least 1 or 2 problems?
Yeah.
Okay. So like, let's say you wanted the probability that a person is both male and colorblind, you would multiply these numbers. Male and not colorblind, same thing. Where it gets more tricky is when you ask, like, what's the probability that just a person in general is colorblind? You would need to go down both male colorblind, female colorblind, and add them together.
All right.
If you want the probability that they're not, that a person, just a general person, is not colorblind, you would go down those paths. Okay, but this question is more sophisticated. It says, let's go back and look at it. If a colorblind person is chosen at random, what is the probability that the person is male? So there's a couple of ways to do this, but I sort of just jumped to, like, we literally do need to know the probability that someone is colorblind.
Okay.
So that's the 0.5 times the 0.05 plus the 0.5 times the 0.0025. Now this group right here are the males. This group right here are the females. Which do we want in this problem? We want to know the probability that the person is male. So it's like, this is our total, and we just want the ones that are male. Okay, so in terms of like what this problem is, it's saying the problem male given colorblind. So on the bottom, we obviously want the total. We want all the possible males that are colorblind as well as the females. But then up top, the only ones we care about are this male group. And this is very common in these types of problems, these conditionals, where you just grab one of the terms from the bottom and that goes in your numerator. So you can obviously calculate these values individually. So like, let's say we wanted the probability that it was female given colorblind. Well, we would be using the female in the numerator instead of male. All right, so if you're doing this in your you said you don't get a calculator, so just, I mean, if I were doing this in Excel, I would probably do the row one, I'm sorry, the numerator in a cell, and then the denominator another cell, and then add them together to avoid issues with parentheses. So let me get these numbers for you. So this is 0.025. This might actually work out nicely. All the numbers are kind of nice. This is 0.02625. Yeah, so this ends up being 0.95238. Maybe more decimals than that. Any questions on that, or anything you'd like me to cover on that question again?
No, I don't think so. I'm just going back over it.
So we could similarly ask, like, what's the probably that you're male, given that you're not colorblind? And so the whatever the given is, in this case, the given was colorblind or not colorblind, you really want to calculate that first.
Okay.
Because that's like your new sample that you care about. You don't care. I mean, those are the ones that you want to grab.
Yeah, and that's the one that ends up as the denominator.
Exactly.
And then sometimes, like on the sequencing ones, not on the sequencing ones. What would you call this?
This is like a Bayes theorem.
Okay, and
Type of
like on
problem.
some of these ones though, you can find like what should be in your numerator is sometimes in the denominator.
Yes.
Like in this.
Well, it's almost always there, because it's always, you're always grabbing it again. I mean, you're not going to get there's more sophisticated ones where they're complements, and yeah, you're just not going to get those.
Okay.
All right, so did you want us to go through more the practice problems that are below assignment 4, or move on to something else?
I think so I wanted to see what does, there's something called assignment 7 that's like pages down that he
Okay.
mentioned.
Yep, there it is, assignment 7. We can go to that.
Yeah, can we go over that?
Yes.
So no, he's just been going down this packet, so then if I have stuff to look at during it, be better.
All right. So I have a friend who he's working for a company. The company isn't doing real well. It's a startup, and he's got to kind of decide, like, hey, do I want to go find another job, or do I want to stay and maybe, take some risk with these stock shares that he's been given? And that's essentially the type of problem you've got here. So this actually does happen pretty often in real life. And whether we actually do this, it's like, hey, do I there's two opportunities, or there could be more than two, and you assign a probability to each. Even if you don't think you're doing it, you probably are. So this is pretty similar here. It says, consider a $2,000 investment in a computer company. There is a 50% chance that this will result in the investor receiving a check for $20,000. Otherwise, he receives nothing. So in these problems, there's always an event X and a probability of X. Okay, so in both cases, the person's going to spend $2,000. So sometimes you draw like a diagram, especially the first time you're like, okay, like I'm going to invest 2,000 no matter what. That means you're losing 2,000 immediately. It's not really an investment, but I either get 20,000 or I get 0. But you're not really getting 20,000. You're getting 20,000 less the 2,000, because you have to consider the initial amount that you put in, and you're not getting 0. You actually put in the 2,000. So you're losing 2,000. So these are the two events. The two events are you either gain 18,000 or you lose 2,000. And if you need to, you can come off to the left here and even like sort of give a description of what they are so that you know. And this is unrealistic. There's no way you would get a 50% chance, but that's the probability of each event. Can you think of something in your life that was like this, where you had sort of two things to decide on?
I mean, I'm sure, right? Like they kind of come up like every day, right? I'm trying to think of like a big one. Like I guess a big one was I was always into sports. Like I've talked about that. Like sports kind of carried me through my life, and then I was done playing them going into my senior year of high school. Surprisingly, like I just wanted out. And that was the whole reason. Like I was fighting with the private school because they let me go there for free for playing sports, and I was like, I don't want to play them anymore. I had failed all of my foreign languages up until that point. And so like my mom was like, well, you're going to end up at Saddleback either way. Do you want to start a semester earlier and just start to learn how to become an actual student? Or do you want to like sit on Rosetta Stone your entire senior year and like struggle to graduate and still end up at Saddleback? I was like, okay, you're right. I was like, it kind of does suck. She's like, yeah. She's like, you know, you will be a high school dropout. That sucks. But she's like, you know, you're going to a 4-year anyways. Like that's what you're going to probably do and all that. I was like, okay.
Right.
So it took me a couple weeks, but that's like what I ended up doing. So I am technically a high school dropout, but I had to like weigh that.
Yeah, and it's not always money that's here. I mean, most of the problems we're going to look at are going to be money, but it could be like time. It's like, well,
Yeah. Yeah, that was
you
one of
know,
them, I guess. Yeah.
I'm gonna gain 6 months, or I'm gonna lose a year, but I'm still, and
Yeah.
yes, I mean we do all these things. So this is a fairly common thing to do. Now, in terms of, I'm gonna write a formula here. In terms of how to find expected value, the formula is the summation, which we're not going to do, but I'm just going to write it this way: the summation of x times p of x. Okay. And all that means, and you generally just want to do this in your table here, you want to multiply x times p of x. So 18,000 times 0.5 is 9,000. Minus 2,000 times 0.5 is minus 1,000. And then this sigma right here just means sum, means to add them up. So in this case, you would add them up and you get 8,000. So the expected value of this scenario is you would gain $8,000. And the idea is that if you were to do this over and over and over again, you would on average expect to get $8,000, which sounds pretty good.
Yeah.
But it's too good to be true because
As far as like a realistic scenario, right?
yeah, because you would never, these probabilities are not even close to correct for what this type of return would be. And if you had $2,000 to invest, I mean, you're probably better off putting it in your pocket than this. I mean, this is a long shot here, in my opinion. But that's sort of aside. That's outside the scope of all this. It's like when your friend comes to you, hey, I got something that, we just need a little money and you're gonna get your money back. And you're looking at your friend, you're like, I don't know. Feels like maybe a 5% chance that this will work. So
Yeah, it's one of my things. Like if it's always like I'm a risk adverse person when it comes to money, like just not into gambling or those kind of things. Investing scares me and stuff like but yeah, when people have come ask me for money investments, I'm like, okay, if it's really that good, then like you should either easily be able to get like your investment or just take all of your own money. But like I'm good.
Right. So this, but the way these problems work is if your outcome is positive, okay, you're gonna do this. Now, are you, I don't jump in, but so let me just go off to the side here. So have you seen a roulette wheel in your life?
Yeah, like again, like on like a Vegas or something like that. Yeah.
So it's 1 to 36, okay, but there's two more numbers. There's 0 and 00, and now you're gonna finally know why they're there. So there's a total of 38 numbers, okay. So if you and half of these are black and half of these are red. So if you, so the probability of black and red is not really 50% because you got these two other ones here, they're actually green. And so in terms of your X and your probability of X, okay, when you go to a casino and you want to play a roulette wheel and you think, oh, I'll just bet black and red, you're going to see what the problem is. So your black and red is like your probability of a black or red is 18. Let me put it over here, black, red, and then green. So your probability of black is 18 out of 38. Red is 18 out of 38. And let's see here. Let's say we play a game. Green. This one's 2 out of 38. Okay. So let's just say you wanted to only bet black and red. Okay. And you have to bet $1 or something each time you're going to play. So you win back your money, but you don't always win it back because sometimes you're going to lose your $1 and you're going to win $1 on these other possible ones. So I'm sorry, your expected return on this, because you're putting in $1 but you're losing it. Let's just say you win a black, you put $1 in, you lose $1, so it's net zero. This is where the casino is making their money. They know that every so often the people that just bet black and red, eventually it's going to hit green. And if you do that long enough, it doesn't seem like a lot, but think about the money totals being a lot higher, then they're going to always get this, because you can't just black and red. If the only two outcomes in a roulette wheel were black and red, the game you would never lose any money playing, because you could just bet black or red all the time. But because of this other outcome, that's how the casinos are winning. They've always got a slight edge. This is the house edge, essentially.
Did that game start with that?
I do not know.
Okay, I was just wondering because I've always wondered that myself. Like as far as people talk about roulette, and yeah, I always just wondered how it was like calculated down, and like I didn't realize that there was two green ones. So
yeah, and that's why there's in the Old West there was another game that I can't think of, but they basically just put numbers on a board, and they always had a guy that was really good at numbers, and he would assign probabilities based on what was there. And it's not that hard to do on the fly, but you had to someone who wasn't drinking alcohol, and but it was always the same. The thing was the same. You're always trying to create a scenario where you have a small edge, because if enough money's in play and you do it long enough, then you're gonna
is craps similar as far as, is it like a thing of probabilities or no?
yes.
Okay. I don't know how to play it, but like
Yeah.
being on the basketball team, the kids like at lunch or just like on road games, whatever, they would always be playing craps. So I'd always like watch because it was just like entertaining, but I had no idea what was going on.
Yes. But whoever's running the game has the edge, so
Like, okay, yeah, because there was always like the guy with the dice, and he was generally the one counting and stuff. Okay, so he's the one with the dice.
well, so in that scenario, they're supposed to, the person holding the dice rolling them, they're the player. They're not supposed to have the edge. I mean, if
they're not. Oh, okay,
created up,
they're the ones. Okay, yes, that's how
Yeah.
little I know. I had no
Yeah.
idea what was going on.
Yeah.
They were the ones always like yelling stuff out and whatnot. Okay.
Yeah. All right. So a potential customer for a $20,000 fire insurance policy has a home in an area that, according to experience, may sustain a total loss in a given year of 0.001, a 50% loss, the probability of 0.01, and a 20% loss with a probability of 0.1. Ignoring all other partial losses, what is the least premium that the company should charge for yearly policy in order to break even? So this is it's kind of odd. Usually they do these problems where you either get all the money or no money, because you don't. I mean, that's typically how insurance works. You either get money because you have a total loss, or you just pay your premiums in each year. So this is a bit more complicated, but if you think about the scenarios, the scenario is you either have a total loss, a 50% loss, or a 20% loss. And they give you values for that: 0.001, 0.01, and 0.1. So in terms of like what what a total loss is. A total loss means that they have to pay you, the insurance company pays you $20,000. So we have to decide whether we're looking at this from the perspective of the insurance company or the person. Which do you want to do? Do you want to look at it from the perspective of the insurance company or the human?
The person.
Okay, so the person would gain $20,000 and a total loss, but they also have to pay in. They have some sort of premiums that they're paying in. You're paying insurance, or your family's paying insurance for you. A 50% loss means that you get $10,000, but you're still paying in some premiums, which are the same, by the way. And then a 20% loss means that you're getting 20% of that. You're getting $6,000, but you're still paying in your premiums. Is that clear? Is that okay?
Yeah.
Okay. So I don't have enough room here, but in terms of our table, X and P of X, the first event, we'll call the first event your total loss. It's 20,000 minus P. I'm going to use P to represent premium, if that's okay.
Yeah.
And the probability of that is the 0.001. That's the probability of a total loss. It's not the 100% loss. It's the probably that a fire totally destroys your home. Okay, and then the next one is you get $10,000, but you've had to pay in your premiums, and that's got a probability of 0.01. Okay, and then the next one is $6,000 minus your premiums. That's 0.1. But there's this other event. Remember, your probabilities have to add up to 1. Okay. So that's the probability that you just pay in your premiums and you don't get any money back. That's why it's minus P. That's why I asked if it was your perspective. So from your perspective, what we don't know the number, but let's just say it was like $100 a month. You're losing $1,200 for the year because you're not going to gain anything. So the number that goes over here is 1 minus 0.001 plus 0.01 plus 0.1. It's the one that's left over. It's what is that? Let me just grab a calculator so I don't mess this up. It's still early. 0.1. Yes, 0.889. Okay, and then I mentioned this before. You really want another column here where you multiply these together. Unfortunately, this one you don't get. You don't get a number. You get an equation. So times 0.001. 10,000 minus P times 0.01, 6,000 minus P times 0.1, and then minus P times 0.889. Okay, so if you were to add all these up, and I know it looks bad, but if you were to add all these up, you would get a the answer. Now you said you're allowed to use Excel.
Yeah.
Okay. Let me really quickly go to that, and I'll show you how to do this by hand or in Excel. Okay, so let's call this the premium that you're paying. And this is for the year. And I'm just going to make up a number. I'm just going to call it $1,000. And then I'm going to make a table. So let's go X, P of X. Okay. So our X is 20,000 minus this number here, which I didn't put in the formula. 20,000 minus, actually, I won't make this too sophisticated. Okay. Minus that. And then 10 equals 10,000 minus that number equals 6,000 minus this number equals minus this number. Okay, and then we have those probabilities 0.001, 0.01, 0.1, 0.889. And then we're gonna multiply them together. This is gonna come together real quickly here at the end. So we're gonna multiply. Now the reason you're getting numbers here is because I've given you numbers in this, and then we're gonna sum them up. So equals the sum of this Okay, and you might say, hey, Matthew, like that's not 0. So that number needs to be 0. And that's the whole point here. So there's this thing called goal seek. Let me find it here. Why? Oh, there it is. Analyze data. No. Okay, here it is. What if analysis goal seek? Okay. And this is really cool. I've used this just on a personal level a bunch. So we want to set cells that we want that cell to be 0. And we want to change this cell right here. Okay, so I'm going to hit enter. There it is. It's magic.
Oh, so it figured out how to.
Yes, it uses what's called a Newton's method to solve this. The same thing that we would do by hand. But because the other way to do it is you have to multiply all those numbers in and move terms around and add and divide. I find this pretty handy sometimes, but you can only change one cell. So it's like if everything's dependent on, one number.
Okay. Yeah.
Sometimes when you're budgeting, it's like, you got all these things. You're like, well, let me just figure this out here. Like, how much money would I need if I wanted to put, 20% or 10% in retirement, or I'm going to give 10%, or, all this stuff. And you can sort of work backwards. But if this wasn't clear, we can of course do it the longhand way, or you'll see it in class. But goal seek is very useful for this.
Okay, cool.
All right. Is there anything short maybe I can answer? We're pretty much at the end of our lesson here. You can see we're going through fewer problems as we sort of move through the course. It's not as fast to go through problems.
Yeah, just more. It's harder. No, I think we're good.
Great.
Good stuff today.
If you plan to schedule with me again, just give me more notice. I am getting busier. The more you can give me, the better. And
Okay. All right.
Thanks so much. Hope you have a great rest of your holiday.
Yeah, you as well. Oh yeah, I told. By the way, I'm so bad at that. I had no idea until like Saturday that I had work off and everything today. So like, yeah, sorry about scheduling you on the holiday.
No problem. I was happy to do it.
Yeah. My mom, I told my mom, I was like, Labor Day's, or I was like Monday's a holiday. She's like, yeah. She's like, you also need to be working harder if you don't know when holidays are.
I agree with your mom on that.
So yeah, it was pretty funny. But so sorry about that. But thank you again. That was helpful.
You're welcome. Have a good day.
You as well.
Bye.